right. You already know some things about inverses, although as far as like a class, I don't know that you've learned about inverses formally, but you probably already know some things about inverses that you don't really even realize. So an inverse is a function that will undo what was done by an original function. Okay? The notation that we're going to use for this would be f, and then we'll use a little -1 exponent of x. Okay? So it looks like you've got an exponent of -1 there, but we would read that as the inverse of f of x, is the way that we would read it. It's used to denote the inverse of a function f of x. You may also see something like g inverse of x or h inverse of x. You could use the letter, could be different, but you're still going to have that little exponent there. So I put a couple here that I think you guys already know. All right, that I don't even have to teach you anything about. So if my function is x minus 5, okay, what would the inverse of that function be? What would I do to undo what was done by f? I'd do x plus 5. Right? So you guys already know these really simple ones, because the opposite of subtracting 5, or the inverse of subtracting 5, we should really say, would be adding 5. So some of these are pretty simple to figure out. Others are going to be more complicated. All right. If I had my second example here, I've got f of x equals -7 times x. What would my inverse be for that one? What? It's not going to be 7x. That's not a bad... you're getting it. I like the fact that you're dividing something. So x is my, like, what I'm doing something to, right? So what was I doing to that x in the original function? Multiplying by -7, all right? So what is the inverse of multiplying by -7? Not 7 divided by x. X divided by -7. Okay? And so the inverse of multiplying by -7 is to divide by -7, right? If I have a number and I multiply it by -7, if I take 15 and I multiply it by -7, it's going to give me -105. If I take that number and I divide it by -7, it gives me back what I started with. All right, so it undoes what was done. Okay, so we're going to look at several different things about inverses. Okay, the first thing that we're going to look at, if it'll go to the next slide, like I want it to. Well, wait a minute, this arrow will work. Okay, there we go. All right, the first thing we're going to do is that we're going to graph these. Okay, I'm going to just graph it for you right now so we don't have to pull out our calculators, but you can, or pull out our computers, but you can do this whenever we get here. So if I graph f of x equals x plus 6 and g of x equals x minus 6. Okay, what things do you notice about this? Okay, my lines are parallel. Anything else? What about my x-intercepts? What's my x-intercept for that red graph? -6, 0. What about on the blue? Okay, so x-intercepts are opposites. Does that happen on the y as well? Yeah, it does on this one. Now, some of these things that we're looking at only happen for these particular problems. But I want to add in one more line right here. Add in this green line right here, y equals x. Okay? What would you say about that line, y equals x? What can we say about it? It's in the middle, right? My question is, would it always be in the middle? Let's think about it. What about if what about instead of plus 6, I had plus 9? What would the inverse of plus 9 be? Minus 9. That's still in the middle, right? What if I had, let's try this. What if I had 3x? What's the inverse of 3x? X over 3. Oh, no, is it in the middle? Kind of. It crosses it though, right? It's in the middle in a different way than it was. What about if my original was like x divided by negative 5? What would the inverse be? X times negative 5, right? Or I could do negative 5x. Oops, I did x minus 5. X times negative 5. Okay, it's still kind of in the middle in a way, right? So what has happened here, let me go back to the original, x plus 6, x minus 6, is the function and its inverse are reflected over the line y equals x. Okay, and that line, y equals x, is just this green line that I have here that goes through 0, 0, and it has a slope of 1. It cuts the first quadrant and the third quadrant in half, right? It just cuts our coordinate plane in half diagonally is what it does there. And so if I reflect over that axis, or over that line, it's a little hard to do because, if we want to reflect something, you can think of like taking your paper and folding it and then making the other half show up. It's a type of symmetry that we have. The slanted line makes that a little hard to see sometimes. It's not too hard to do with this one. It was a little harder whenever we started having everything cross, right? So there's some other ways that we can know about these. Let me show you here. Okay. All right. So actually we're going to do this by hand, not with this one. With the next one, it says the ordered pairs of the relations 1, 3, 6, 3, 6, 0, and 1, 0 are shown below. We're supposed to graph the inverse of the relation. Okay. So in an inverse, what's going to happen is our x and y coordinates are going to switch places. So let's write that over here in a different color. Let's do red. X and y coordinates switch places. So that would mean that 1, 3, what would it become? 3, 1. And actually, let's see. 1, 3 is that. Let me go back to my colors and we'll make this match if I can. Okay, so 1, 3. What color is 1, 3 on that graph? It's red. It's this red point right here. So if I flip it, it would be 3, 1. So 1, 3 becomes 3, 1. That's this point right here. Okay. Then 6, 3. What color is that one? Blue. It's my blue point right here. 6, 3 becomes 3, 6. So 3, 6 is right here. Okay, let's see if I got purple. Oh, got purple. Oh wait, I need green right now anyway. Green is 6, 0, right? 6 zeros is going to become 0, 6. So 0, 6 is right here. And purple for our last one, 1, 0 becomes 0, 1. So 0, 1 is right here. Now I'm going to put like a dotted line between these so we can kind of, here was our original. This was our original. No, they're not actually connected. I'm just drawing this so you can kind of see where it's at, right? And then our new graph, let's use a dotted line to show you where that new one is. Okay, now, if I graph the line y equals x, ooh, let's not use that. How do I make that smaller? If I graph y equals x, that is the line that cuts the first and third quadrants in half. Right here. Now, look at, it's a little hard to see, but look at the red points. What do you notice about those? Same different distance away, right? What about the purple? They're the same distance away from that line. Just a green, same distance, and the blue are the same distance. If you think about just taking all those points and flipping it over that line, that gives you your inverse. Now, sometimes it's hard to do because I would have had a hard time doing that just by looking. Other times it's pretty easy to do. It just depends on the question, on the problem. So, but this is one thing that can help us. We can switch our coordinates there. So, let's look at this problem. Okay, this gave me a function here that has these points. I need to graph the inverse. Before I do, I'm going to draw in that line, y equals x. Right here. Now, some of these I can do without having to even think about it. This point right here is going to end up right here. I can tell where that's going to be pretty easily. This point right here is going to end up right here. I can see where that one's going to be pretty easily. What happens if the point is on the line? It just stays where it's at, because like if we think of flipping it on that line, it doesn't change because it is on that line. So it would just stay where it's at. But now, when I get up here, that's a little harder to see. Maybe I think about here. That one I'm really unsure of. So the other way we can think about this, if I had the point 1, 2, which was this point right here, it becomes the point 2, 1. The point 2, 4 is 4, 2. The point 3, 9 is 9, 3. The point 4, 4 stays 4, 4 because the two numbers are the same. And then the point 5, 12 is 12, 5. So sometimes you can do it just by looking, and then sometimes it's really hard to do it by just looking, and you can switch your points. So if I check to make sure I've got this right, this is the point 2, 1. There, that one's good. 4, 2. 4, 2 is right there. I've got that one already. 9, 3. 9, 3. That's right here. That's one of them I had not done yet. That matches with this point right here. 4, 4 is on the line, so it did not move. And then 12, 5. 12, 5 would be right here. Okay, it does ask us this question, is our inverse a function? The red dots. Did they pass the vertical line test? No. I can either tell because right here we do not pass the vertical line test, or I can tell because in my X line I've got a 4 here and a 4 here. So Was my original a function? It was a function, right? So just because your original is a function does not guarantee your inverse is going to be a function. Okay. And I think I forgot to put on here, on these notes, when you can tell. But we just may not worry about that. All right, so let's look right here. Okay? I've got two functions graphed below. I want to know if they are inverses. Okay, what do you guys think? Think yes? Think no? How could we tell? Let's start by putting in that y equals x line, which is just, we're just going, you know, like up 1 over 1. If you're not sure where I'm getting that line, just up 1 over 1. And then down 1, left 1. This way. Let's make it like that. Maybe that'll help us see. Alright. If I take the purple line and flip it over that green line, will I get the black line? I think so. But sometimes some people are better at visualizing that than the other. It looks like probably, but I'm not certain. What's another way I can check? I can look at the x-intercepts, although it won't necessarily be like a positive and a negative. It was on the one we looked at. But if I look, oh, that's not even the x-intercept. Actually, well, I'm going to actually not look at this x-intercept. Let's look at the x-intercept right here because it hits at a grid line, right? Right here is 3, 0. If I have an inverse, then I should have the point 0, 3. Right there it is, right? We can pick other points. What are the coordinates of this point right here? 2, 7. So that means what should be on the other graph? 7, 2. 7, 2. It's right here. That's on the other graph, right? If I check, you know, maybe a point down here, the coordinates of this point are negative 7, negative 5. That means negative 5, negative 7 should be on the other graph, and it is, right? So you can check a few points to see if it's checking out. Now, it's possible for a few points to work, but not all of them. But if you check 3 or 4, you should see, you know, that it's making sense. So these are inverses. This will be a yes. They are inverses. So we're going to learn several ways to tell if things are inverses, but one way you can figure it out is to type it into Desmos and see if they look like they're inverses. Look like they're flipped over that line y equals x. Okay? All right, what do you guys think about the next one? They're kind of flipped, but let's put in that line that they're supposed to flip over. If I put in this line right here, I'm not feeling as good about that one. Let's check some points. This one doesn't have a ton that are like on grid lines, but right here, that is the point negative 1, 1. That means 1, negative 1 should be on the other graph. 1, negative 1, is that on the other graph? No, it's on the same graph, right? So that is not checking out. I could check another point, maybe like right here at 2, 4. That means 4, 2 should be on the other graph. 4, 2 is out here in space with nothing, right? So this would be a no. Those are not reflected over that line. Okay, questions? Okay, now, this one asks us to sketch a graph of the inverse. So just like I've done on the others, I'm going to put that line in. Y equals x. Oh me, that's going to be hard to do, right? That's going to be difficult. Like, it's hard to picture that for me. Some of you may be better at looking at things visually. Some kids are really good at seeing that. But, like, if I think about this point right here, I kind of want to put it up here, but I don't think that's right. So, let's find points on this graph. Let's see. Ones where we hit grid lines. So, these are on our original. Should use red there. So, if I look at the coordinates of those points, I've got -3, 5. I've got -2, 0. I've got -1, -3, 0, -4. This point right here is 1, -3. I got 2, 0, and 3, 5. So if I want the inverse, I'm just going to flip them. 5, -3, 0, -2, -3, -1, -4, 0, -3, 1, 0, 2, and 5, 3. So 5, 3, or 5, -3. Let me use a different color. Let's use purple for this one. Purple. 5, -3 is right here. 0, -2 is right here. -3, -1 is here. -4, 0. -3, 1. 0, 2. 5, 3. So if we look at that purple there, our answer looks like this. I think I probably would have more flipped it upside down if I was just trying to do it by looking at it. But this actually kind of flips it over on its side. Is our inverse a function for this problem? It's not. Okay, questions so far? All right. Okay. So I did put this in here. Good. All right. The inverse of a function is a function if and only if the function is a 1 to 1 function. So it has to pass both the vertical and the horizontal line test. So let's just use Desmos to help us with this. That's not what I meant to do. So if I graph this first one, f of x equals 2/3 x minus 1. Okay, is that function 1 to 1? Okay, it's 1 to 1. So if my function is 1 to 1, then that means the inverse would also be a function. So that would be a yes. Okay, let's look at the second one. X plus 2, oh, gracious me. X plus 2 over x minus 1. Oh. Is that a 1 to 1 function? It's a little harder to tell. Let's see. Let's do vertical line test first. Alright, so here's a vertical line. We only hit once. It's a function. Okay, let's do horizontal line test. Okay, we're only hitting once down here. I can't go any further than that, but I think I'd only hit once. Do I hit twice any here? In the middle, which is where it kind of looks like they might overlap? I don't think so. I think what I have right here is called a horizontal asymptote on that graph. We're just getting closer and closer. So this is looking like it passes both, and it does. So this is also a yes. Okay, your inverse of this would also be a function. Let's look at our last one. What about this one? Does this one pass vertical and horizontal line test? Which one does it fail? Horizontal. It's going to hit twice whenever you use that horizontal line test. So this is still a function, but its inverse would not be a function. So I'm going to say no. Inverse is not a function. And that's what we were seeing on our other ones that we looked at that. The functions where our inverse was not a function, it was because we did not have a one-to-one function to start with. Okay. That does mean that some of the equations that we're going to look at don't have an inverse function. You can write an inverse relation for it, but you can't write an inverse function because it's not actually a function. We won't get too much into that. All right. Let's learn how to find these by hand. Okay. This is one of the most important that you're listening to. I know this is a super exciting lesson today, but one of the more important things that you'll see. So, this is how we find the inverse of a function by hand. Okay? So, the first thing that we're going to do is we're going to switch the x's and the y's. So, that means where the y is at, I'm going to put an x. Where the x is at, I'll put a y. So, I will put x equals 2y plus 4. All right. Then I am going to solve this new equation for the y. You're not going to get a number. You're going to get like a new equation for this. Okay? So, William, if I want to get that y right there by itself, what would I do? Well, I already switched my x and my y's. Now I'm going to try to get that y by itself. So I got to get rid of the 2. And I got to get rid of the 4. Which one would I mess with first? Just like solving equations, you want to go like furthest away. So you want to do the opposite of that plus 4, or the inverse of that plus 4. What would that be? Instead of adding 4, we will subtract 4. Now, the problem is like normally we're solving equations, and normally we'll get a number over here. Can you do x minus 4? You cannot. So you're just going to call this x minus 4 equals 2y. Okay. Again, we're still trying to get that y right there by itself. So, Alvin, what should we do to get rid of that 2? Is it added to the y? No. It's not. What do we got to do? Divide. Because it's right beside the y, meaning it's multiplied. So the inverse operation for multiplication is going to be division. So we're going to divide by 2. So now we can write this a couple ways. I'll show. It's okay with me if you leave it like this. It's just when you got multiple choice questions, sometimes they won't. So I'll show you something else you can do here in a second. But it's all right if you leave it like this. The y now is by itself, so we are done, which means that we're to step 3, which is just to replace the y with f inverse of x. So f inverse of x would equal x minus 4 over 2. Okay, now it's possible that they won't leave it like this. This is x, it's like it's got a 1 in front of it. And if I'm dividing by 2, what that means is I'm dividing this by 2, but I'm also dividing this by 2. One of the, Miss White, the teacher that taught calculus before I took it, she used to call this the love connection, because whenever you circle it like that, it makes this cute little heart right here. So if we divide, we can divide both of those. Another way you could write this if you divide is you could write it 1/2 x minus 4 divided by 2 would give you 2. Now, I don't care which way you write it, but you may find yourself in like a multiple choice situation where you got to know maybe this isn't given as your answer. You'll also be able to use Desmos, so you could just graph them to see which one works too. Okay? Yes? You want to use the pass? Yes. All right. Okay. All right. Let's try this one. Okay. All right. Now, I've got an f of x here, but what letter can I think of that as? It's like your y, right? So we have to switch our x and y's, which means I'm going to put x here, -4 minus 5y divided by 2. All right. I have got to solve for that y right there. All right, so if I'm trying to get that y by itself, Aiden, what do you think I should do first? Multiply by 2, because it's divided by 2 on this side. We're going to have a hard time while we got that 2 down there, so I'm going to multiply by 2. It'll cancel. Multiply by 2 over here. So now I've got 2x equals -4 minus 5y. All right, so now I still have this -4 and this -5 that I've got to get rid of. Shay, what would I do next? Almost. Since it's a negative, we need to add because we're going to do the opposite. So we'll add the 4. Oh, what's 2x plus 4? It's just 2x plus 4. We can't do anything with it because they're not like terms, so we just write 2x plus 4. You should get another equation at the end. You won't get a number, right? If you get a number, you probably did something wrong. All right, so this equals -5y. Elijah, what's the last thing I would do? Okay, good. I'll divide by -5. It's not letting me write that, though. No. And so when I do that, I'll have 2x plus 4 over -5 equals y. And I could write that back with my inverse notation. So that would be my inverse. And I didn't do this on the last one. I should have. I can check this. One way I can check it anyway. Sorry. That made it all go away, didn't it? I'll put it right back up. One way I can check this is to graph the original. And then I can graph the inverse. I'm going to call it g of x because it doesn't like it if I try to use inverse notation. 2x plus 4 over -5. And if I graph the line y equals x, does that look like that's reflected? I think so. It's a little hard to tell sometimes, but I think so. Just to give you an example, one that wouldn't look reflected, like, let me make this a -4 right here. That'd be wrong. See how it doesn't, like, cross at the same point right there? That would not be reflected. Okay? Go back to full screen in case you didn't get that. right, I want you guys to try the next one. But there's probably a little trick on that. How do you get rid of a cube? What? Almost. To get rid of a square, you would use a square root. To get rid of a cube, use a cube root. A cube root is, you write this, if you just see the root like this, you assume that that is a square root. A cube root has this little 3 right here. So, you're going to need that on that problem. Try that one on your own.
She said we can't look that now.
Alright, what's the first thing you're going to do? Switch your X and Y. So try it. Write that down. And then once you get that done, go get your computer out. I want you guys to use that nice on the last couple of those. I'll wait for you to actually. Probably. Okay, let's look at this. Alright, I'm going to switch X and Y's. This is like my Y. So I'm going to have X equals, oh, sorry. Here we go. Y plus 1 cubed minus 2. The first thing you're going to get rid of is that 2. So you'll add the 2. X plus 2 equals Y plus 1 cubed. Okay? What's the next thing you got to get rid of? The cube, because you're always doing furthest away. How do I get rid of the cube? Cube root. So I do the cube root over here and the cube root over here. So I've got cube root of X plus 2 equals, the cube and the cube root cancel each other out, so we just have Y plus 1 here. And what's the last thing I need to do? To get that Y right there by itself, subtract the 1. Now, be careful with this. This stuff is underneath the cube root. You cannot subtract 1 from that 2 right there. So you're just going to write it like this, cube root of X plus 2, and you're going to put your minus 1 over here on the end. So your inverse here is going to be the cube root of X plus 2 minus 1. Now, solving these by hand is something I want you to be able to do, especially in the easier cases like that first one that we saw. But they can be a little tricky, so I'm also going to show you a trick. It is a lovely Desmos trick that feels like cheating. It helps so much. All right. Everybody pull up Desmos. So I want everybody to have this on their screen. And I'm going to show you a Desmos trick that should really be illegal, but it's not. So this is like a tax loophole. You might as well, if it's not illegal, you should just go ahead and use it. And it's going, I mean, this makes it so you don't have to know how to do it by hand at all. If the questions are multiple choice. Now they could ask you a question like, Marley solved this by hand. Here's step 1, step 2, step 3, step 4. Where did she mess up? Then you have to know how to do it by hand. That's about the only way they can ask you how to do this, where you have to be able to do it by hand. But if they ask you the question like this, multiple choice, and ask you to find the inverse, then we could do it by hand, or we could also do it this way. Okay? All right. What is our first step whenever we solve these by hand? Switch the x and y's. I'm going to do that. X equals 1/2 y minus 4. That is my inverse. Okay? Because I have switched the x and y's. Desmos will graph it even if it's not a y equals. In the old calculators, in those yellow calculators, everything has to be solved for y. It makes it complicated to type it in. Desmos will graph anything. So this is the inverse because we switched our x and y's. So all I got to do is see which one of these matches this. Can somebody tell me which one I need to look at first, just by looking at this graph? Where's the y-intercept on this one? 8. Which one has a y-intercept of 8? This one right here. Now sometimes it's not that easy to tell, but on this one it is. So if I graph, I'm going to call it g of x. It doesn't like it if you try to type in that -1. If I graph g of x equals 2x plus 8, it's the same line. That's my answer. The other ones, if I try 4x minus 2, y equals 4x minus 2, that's not the same line. So that's not the answer. So this one would be C, because that is the correct answer. Now, this is not going to help you when it's not multiple choice. It will let you check your answers. I'm going to give you some things that are not multiple choice on a few of them, but a lot of these, they got to ask you multiple choice. And let's go to the next one. Try that one on your own on Desmos. To do a cube root on Desmos, if you go down here and go to functions, I think it will, maybe, yeah. At the very bottom so to get to a cube root, at the very bottom right here, there's like a n, and then it has a square root. If you click that, it'll let you put a 3 right there. So to type that in, you'll do functions, go down to the very bottom. It's that n root there. So like to type in the original equation, I'm going to go ahead and switch my x and y's. X equals, we'll do cube root, so we'll put a 3 right there. Y minus 1. Make sure you hit over before you hit minus 2 so it's not on the inside of that root. Here's what my answer should look like. Now, you might just have to check your answer choices on this one. There's not an obvious giveaway of which one's going to be the correct answer. There is one that looks like, which one would you guys check last, like kind of throw out on this one? I would throw out B. Why is B different from the other problems? It's got a 5th power. Does a 5th power have anything to do with a cube root? That'd be like a 5th root, right? So I doubt it's going to be B. If nothing else works, try it, but I don't think it's going to be B. In fact, I kind of doubt it's going to be C either. Somebody else said C, because to undo a cube root, you need to raise it to the third power. You wouldn't use another cube root. So I don't think it's going to be C either. I'd check A and D first on this.
Go to functions on your computer.
No, I wouldn't type. Yeah, or ER. It was right here. Where is yeah. Then, oh yeah, yeah. How do you
Which one? You guys think A? Anisha says A. Alright, so if I graph A, instead of using that F inverse, I'm just going to say y equals x plus 2 to the third plus 1. It's the same, that's the answer. Okay, if you look at D, minus 2, that's not the answer. Because if you're using this trick, the answer choice is going to be the exact same as what yours looks like whenever you switch your x and y's. Yes?
I'll put that in. It's not working.
Whenever you type, has it got the exclamation point over here where it says it won't graph it, it's not graphing anything? Okay, I'll go look at it. All right. Okay, you graphed the, okay, so let me show you guys what Carlos has, okay? Carlos has this. Carlos typed in the original. And then he typed in A, which is y equals x plus 2 to the third plus 1. So he typed in the original. Now, I can still tell these are inverses, because if I type in y equals x, I can tell they're symmetric, right? But if you want the really easy way, go up here in that original, Carlos, instead of typing it in exactly as it is, turn that y to an x and the x to a y, and then these two will be exactly the same. I'll come look at yours in a second. Did you figure out what you did?
Yeah.
Okay.
I put 2 X's.
Yeah, that if you put 2 x's or 2 y's, it'll mess it up. I saw that also. Okay, this one's super hard. Ugh. That one's awful. But we can do the same way, right? So if we do x equals negative 2 plus, to get to cube root, you got to go here to functions, go down there to the bottom, cube root of 4x over 2. Oh, what did I do wrong? Mine's just a line. That can't be right.
Oh, you didn't switch.
I didn't switch this one to a y. I did the same thing Aiden did. Need an x here, a y here. All right. Which answer choice do you guys want to try? Either A or B. I don't think it's going to be C or D because they have that fifth power. So let's try 2 times x plus 1 to the third. It's A. I think I put my answer choices in order too much on these. So A would be our answer there. Okay? Alright. Okay, so just to review, there are several ways you can talk about inverses. The graphs will be reflected over the line y equals x. If you have coordinates, you can switch your coordinates. If you have equations, you're going to switch your x and y in your equations. Okay? And then it has that note about notations there. So, You may also see some of these that just ask, are these two inverses? So you have two options for this, okay? I could type in f of x equals 6 plus cube root of 4x over 2, which is my first one, and g of x equals 2 times x minus 3 to the third. Okay? Do those look like they should be inverses? I think so, because if I type in y equals x, they look symmetric, right? They look like they've been flipped. So I think so. If you really want to make sure, take one of them, doesn't matter which one. Turn this into your x, turn this into your y, and they'll turn into the same graph. So these are definitely a yes. That's the same graph right there. So 17 is a yes. Right. All right, if we look at 18, if I type those in real quick, g of x equals negative 1 over x minus 3, and f of x equals 1 over negative x plus 1. Oh, to me that one's hard to tell, but I don't think so. It looks like stuff is too close to this and not over here. But if you want to know for sure, take one of them, doesn't matter which one, turn that into an x, turn this into a y. Are they the same graph if we do that? They are not, so that would be a no.